2011 relative velocity question part A. Two cars A and B are traveling along straight roads which intersect at an angle theta to the horizontal, where the tan of theta is 4/3. Car A is moving towards the intersection at a uniform speed of 5 meters per second. So car B is going faster at 10. It's going to get there first. So at a certain instant, which they always tell us in these types of questions, they're 100 meters both away from the junction. So let's create a little diagram to show what's going to happen here. Well, B is 100 meters away, so we can see there in 10 seconds to get there. So in 10 seconds, A is going to go 5 by 10, which is 50 meters. So 100 minus 50, they're going to be 50 apart. So we have B at the junction. We have A here, 50 meters away. And B is traveling in this direction. And A is traveling due east in this direction. And my angle theta is still in here. So my velocities now, the velocity of A is straightforward enough. 5 meters per second in the I direction, so 5I plus 0J. The velocity of B, we have a theta in there too. The velocity of B, I is adjacent to the angle, so it's 10. Well, and it's positive over here for B. So it's going to be 10 cos theta times I plus 10 sine theta times J. Now, anytime they give you the tan in the question, you should probably just immediately write down what the cos and sine are. And it's pretty much nearly always the same angles. Tan is 4/3, opposite over adjacent, so it's my 3/4/5 Pythagorean triple. So the cos of theta is 3/5, and the sine of theta is 4/5. So what's that going to give me down here? 10 by 3/5 is going to be 6I, and 10 by 4/5 is going to be 8J. So this is the velocity of B. So the velocity of A relative to B is the velocity of A minus the velocity of B. So we can see here it's going to be 5 minus 6, so minus I, and 0 minus 8, which is minus 8J. That's the velocity of A relative to B. We have our angle, and the tan of that angle was 8/1. We're looking for this side here, which is, what are we dealing with? Opposite and hypotenuse. Opposite and hypotenuse. So we're going to need sine of the angle. So let's just do a little Pythagorean triple. The tan of A is O/A. So magnitude √65. So the sine of A is equal to x over 50. So 50 times the sine of A, and the sine of A is O over H, 8 over root 65. So 50 by 8 over root 65 is equal to x. So 400 divided by root 65 is going to give me x is equal to 49.6. And we were dealing in meters this time, meters.